Bismillahirrahmanirrahim. Welcome to the second part of the 20th lecture of Statistics and Probability Theory. We will continue with the topic normal distribution as we were studying the reverse use of the standard normal distribution table. Now, this is the table we have. In the previous lecture, we have studied that how to calculate this particular probability or area, or how to find out this area when we know the specific value of z, and this table is giving us the area between mean and some specific value z, which was this all things we have discussed in the previous lecture. And in this lecture, we are discussing that how to find out this value of z when we know this area between mean and the specific value of the z. So we will continue with the examples. Gauges are used to reject all components for which a certain dimension is not within the specification. 1.50 plus minus d, it is known that this measurement is normally distributed with mean 1.50 and standard deviation of 0.2. Determine the value d. So we have to find this value d such that the specifications cover 95% of the measurements. So if we draw it manually, what we will see that this will be the scenario. Let's suppose this green line is the axis, and here we will have the mean here at the center, at the peak, and this is 1.50. So the specifications are this d is some unknown value, 1.50 minus d and 1.50 plus d. So we will have the upper limit and lower limit. 1.50 minus d is the lower limit. 1.50 plus d is the upper limit. So by subtracting something, or you can say by subtracting d, which is unknown, from the mean, we will go in somewhere here. Let's suppose this one is x1. This one is x1, as we are using here axis as x-axis here. Still we are in normal distribution, not in standard normal. If we were in standard normal, then mean should be 0. And if we add something in the mean, it will be here and x2. Let's say this is x2. I'm naming it as x1 and x2. And they are saying that the specifications covers the 95% of the measurements. So it means this area is 95%, or you can say that this is 0.95 probability. So this one is 0.95. So this is the total probability between these 2 points, or you can say this is the area between x1 and x2. So you have to find this value d, which is still unknown. Now, so this is the scenario, this is the mean 1.50, and as this is the area 0.95, and we are using the standard normal table to find out the specific value, and that particular table is giving us the area between mean to some specific value. So we are bound to use this table in this way, because we can read this table only if we have the area between mean to the specific value z. So for this purpose, we have splitted this 0.95 into two parts, which is as this is d is the same value, we will adding and subtracting the same value from the mean. So obviously the magnitude will be same, but in opposite direction. This would be negative and this would be positive when we will in the standard normal distribution. So as the same value is adding and subtracting, so the magnitude will be same in both sides. So we can split this whole area 0.95 into two parts, which is 0.475. 0.95 divided by 2, which is 0.475. So this is 0.475 and this is 0.475. So area between mean to some specific value, let's suppose this is Z1 and this is Z2, as now we are in standard normal distribution, as we have indicated mean 0 here. Here we have the mean 1.50. That's mean we are not in standard normal distribution. We are not dealing with standard normal distribution in this graph, but here I have mentioned 0. It's mean this is standard normal distribution. So now we have to find this value z1. For this we will go to the table and go through the reverse in the body of the table. So we will look at from here 0.475, how close we will be. This is 0.4082, but we need 0.475, so this is 0.42. This is 0.4 and here we have 0.4738, 0.4744, 0.4750. So luckily we got the exactly same value as we want in this particular example or in this particular case. We are not using the approximate one here. So going in this way, so this is 1.9, and by going in this way, this is 1.96. So we have the corresponding value of z in according to this area, or probability is 1.96. So this value is 1.96. This value will also 1.96, but this will have different magnitude, opposite direction. So as this is beyond or before the mean 0, so this will be negative, and this is the at the right side of the mean, so this is positive, and this is at the left side of the mean, so this is minus 1.96. Now you got the values of the random variable z at the specific points, and we know that z1 will be equal to okay, this will be more clear to you, x1 minus mu over sigma. So this z1 is here minus 1.96, and this one is d, as we have subtracted d, and this is minus mu, which is 1.50, and divided by 0.2. By simplifying this, we will get d is equal to 1. Let me wrap this. Okay. Now 1.50. This should be here, 1.50 minus 1.96 into 0.2. So this is the situation, minus 1.96 into 2 plus 1.5, which will be equal to 1.108. So at this point, when we subtract the values D from the mean, we will get 1.108. So this is the value. This is the point, first point. Now we will find out the second value, second point, which will be Z2 is equal to, and it will be D minus 1.50 whole divided by 0.2, and by simplifying this, we will get, this is 1.96 as you know, into 0.2, and this would be plus 1.5, which will be equal to D. So this is the situation, this one, and by simplifying this you will get 1.892. So this is 1.892. So this, we have find these two values, x1 and x2. The first value is 1.108 and the upper limit is 1.892. So this is the way to solve such scenario or such question. Now example number 3. The average grade for an exam is 74 and the standard deviation is 7. If 12% of the class is given as the grades are curved to follow a normal distribution, what is the lowest possible A and the highest possible B? And the find D6. So what we have to find, if 12% of the class is given A's, these are A's, given A's and the grades are curved to follow a normal distribution, what is the lowest possible A and the highest possible B? And also we have to find D6. We will discuss about this D6 in later on slides. First we will go through this, what is the lowest possible A and the highest possible B. Here we have mu is equal to 74 and sigma is equal to 7, and our random variable is following the normal distribution as it is written there. Now an area of 0.12 corresponding to the fraction of students receiving A's is shaded in figure. As you know that the grades are following the normal distribution, so this will be the case. It should be like this. Not so good, but it's representing the bell curve. And here we have the marks, average marks 74, and what they are saying that 12% of the class is given A's. That means that 12% or 0.12 is the probability that the class will get the grade A. So we have to look at the 0.12 on this graph. If you wish to locate 0.12 here, that you are saying that this should be above this is 0.12 area, this cannot be possible firstly, because here we have 0.5 area, rest will be here. And as you know that A is the highest grade and this axis is starting from minus infinity to plus infinity, so it should be at the upper side of the graph, at which the axis has the greater values. Here we have the marks below than the 74. So this is the average marks, and A grade cannot be below the average marks. So this could not be the situation. So obviously 0.12 area will be located here, and this will be the area containing the average marks or average grade, A grade. And as you know that total this area is 0.5, and if we are in standard normal distribution, if we are dealing with this, so here the mean should be 0, and this area, as this point is unknown, let's suppose this point is Z, you can say Z1, I'm just naming it. So this area would be 0.5 minus 0.12. So this would be 0.38. So total area in this particular region between mean and particular point Z1 is 0.38. So what we will do, we will go to the area table and we will see that which value of random variable Z is corresponding to the area 0.38. As you know that now this area is 0.38. So this is the normal table, standard normal table. Let me check this first. And 0.38. If you go through the table, so this is 0.2764, 0.3023, 0.3749, 0.379. So these are two values. And this is more closer, 0.3810, 0.3810 will be more, it should be 0.3810, and yeah, this is the more closer value. So by going in this direction and going in this direction, what we will find that this is corresponding to 1.18. So the Z value is 1.18. So this would be 1.18. So this is the way to find out the value Z, and by substituting it in Z is equal to X minus mu over sigma. It would be 7, sigma would be 7, Z is 1.18, it would be positive because it is at the right side of the mean, plus 74 as the corresponding to this mean. By simplifying this, you will get to know that it is X is equal to 82.26. Therefore, the lowest A is 83 and highest B is 82. So what we get here, we get X is equal to 82.26, and you can see from here that this area will contain the A grade, and obviously below this point will be B grade at some particular level, but we have to find the highest possible B, so it should be close to somewhere here. So as this is 82.26, so what we have taken that the highest B is 82 and the lowest A, as it is starting from here and this is 82.26, lowest A is 83. So this is the way to interpret it, as they are saying find out the highest B and lowest A. So the highest B is 82 and lowest A is 83. As the value of X is 82.26, this 82.26 is representing the cut point above at from there the A grades are starting above it and below from it is the B grades. Further, you have to find the D6. D6 are the as D represents the deciles. Deciles are something which divides the data sets into 10 equal parts, and we have deciles from D1 to D9 as they are splitting the data into 10 equal parts. If you are saying that D1 have 10% area below it. This is the point which have the 10% area below it. If you are saying D2 to find out D2, so D2 is the point which have the 10% area between D1 and D2, and total we have 20% area below D2. If you are saying D4, so it means D4 is a point which have 40% area below it, and if you are saying D6, it means D6 is the point below which is the 60% of the area. So by using this concept of decile, we will sketch it on the graph of the normal curve. So this would be like this, as mean is 74 and you know that till mean is 50% of the area we have, below mean is 50%, above mean is also 50%, and you want to locate a point where below which is 60% of the area. So this is the point D6 and below which is the 60% of the area, total area. So by sketching it, if we are in standard normal curve, this is 0, mean 0, and this is the point D6. Let's say I represent it with Z6. So this is the whole 60% of the area, 0.60. But we want to locate the area between mean to Z6. So what we will do? As we know that total this area is 0.5 and this one is the total 60% of the area, and this is 0.5 and this is 0.10. What we will do? We will simply subtract. This is 60% of the area, 0.60 minus this particular area below the mean, which is 0.5. So this will be equal to 0.10. So this area, this one, between mean and Z is 0.10. So we will go to the table and go through the body of the table and find out where the area 0.10 or approximately 0.10 is located, and we will find the corresponding value of the Z. .10. So where is 0.10 located? So 0.10, this is 0.0910. This is 0.0948. This is 0.0987, and this is 0.1026. So you can select either this one or this one, as you are taking the approximate value. So I am going with 0.987 by going in this way and this way. This is 0.25. We will locate it here, and this obviously this would be positive. Why? Because this is at the right side of the mean, which is 0. So this would be 0.25. By substituting it in this, Z6 will be equal to, here we should have D6, as we are eager to find D6, minus mu over sigma. Z6 is 0. 0.25. This D6 is unknown, minus 74 over sigma, which is 7. By simplifying this, you will get D6 is equal to 75.75. That is 60% of the grades are 75 or less. So this is the way to find D6.